So, hi everyone. Hello, I hope I am audible. So, hi everyone. Yeah. So, my name is Dilshad and I'm here to discuss today's Codeforces contest. Okay. So, it was a Div 3 round. So, the contest is still going on, but I have started recording it. Okay. So Codeforces. Okay, so, let's start with the first question. Yeah. So, let's start with the first question. A positive integer x is a perfect root if there exists an integer y such that root of y is equals to x. Okay, and in each test case we are given uh, and each test case we are given some n and we have to output n distinct perfect roots. Okay, yeah. So we don't really. So in this question we have to output n numbers whose square exists. Okay, so every integer has some perfect square. Okay, so we can just output any set of distinct integers. Okay, so since you have been asked to output n, so you can just output 1 2 up until n. Okay, so that would be our answer. Okay, so the overall complexity is big O of n and overall space complexity is, I guess, big O of 1 because I haven't really stored that answer. Okay, so let's look into the code for once. So just I have just taken the input and I have like I have just outputted from 1 to n. Okay, so that's that for the first question. Let's move on to the next question. Yeah, for the second question, let's read this question. So we are given an array of n integers and the value of the array is the sum of the maximums of each prefix. Okay. So for the first prefix, the maximum is just a of 1, and the for the second prefix, the maximum would just be maximum of a1 comma a2, and so on. Okay, and the value of an array is the sum of these maximums for each prefix. Okay, we are allowed to choose two indexes I and j and swap any two elements ai and aj. Okay, and this operation can be applied at most once, and then after that we have to find the maximum possible value of the array after at most one operation. Okay, and the again the constraints are not that tough. Okay, so what is our value? So value is just summation of like maximum of uh, a1 up until ai, right? For every I from 1 to n, right? You would notice that a1 is in all of them, okay, all of them. So if I can, if I so like if I can bring the maximum element, whatever it is, mx, if I can bring that element to the first position, then what is going to be my value? So my value is just going to be n times mx, right? And that is just our answer. So and like we can swap the number of elements at most once, right? So like even just once is enough. Okay, and if the maximum is at the first position, then we don't really need to do any operation. Okay, that's why they have said that we can do this operation at most once. Okay, so if the maximum is already at the first place, we don't really need to do anything, and if it is not, then we can just swap the first element with the maximum element, and then our answer is going to be just n into mx. Okay, so let's look into the code for once. So as you can see, I have declared this variable mx just to store the value of the maximum element in the array, and then I am just outputting my answer as n into mx. Okay. So that's just for this question. So the overall time complexity is just big O of n, and space complexity is also big O of n. Okay. So let's move on to the next question. So we are given an array of n integers and we are allowed to perform the following operation once. Okay, so select an integer x and for each value I set ai is equals to ai plus x. Okay. Yes, and then for and you can perform the operation itna out. So and then after that we have to output the maximum possible value of mex of a. Okay. So uh, we can do this operation at most once, right? And like even if you do this operation more than once, then it is similar to doing this operation at most once. Okay. So we are allowed to add x to every element of AI. Okay, so adding x is similar to saying that we are shifting the values of the array A by some integer x. Okay, and it can be positive or negative as well. So x can be anything, positive or negative. Okay, and after this shifting, uh, we have to output the maximum possible value of mex of the whole array. Okay, what is mex? Mex is the smallest non-negative integer that is not present in the array. Okay, so if it contains negative elements, so we just won't really consider them. Okay, so we will consider only the non-negative integers and then we'll try to find out the mex in what way? In by the smallest non-negative integer that is not present in the array. Okay, and the constraints on n is 3000. So that is an indication that we can apply some n square kind of what? N square kind of idea. Okay, so first of all, we want to maximize the mex, right? Maximize the mex. So to make mex anything like if you want to make mex greater than 0 in the array, in the whole array there has to be a 0, at least one 0. Okay, at least, right? One 0 has to be there, right? So if you want to have at least one 0 in this array, then what would you actually want? So yeah, so if you want to have at least one 0 in this array, then and let's say all the elements are greater than 0 or not equals to 0. Okay, so like all the ais are just not equals to 0, then what is one way of doing the operation? So we can choose x is equals to some ai. Okay, so if we choose x is equals to ai, then what is going to happen? So this whole array gets transformed into what? So every AI becomes what? AI minus AI, sorry, AI minus X, where X is equals to AI. Okay, so every element, so I should replace this with J. Okay, so every element becomes AJ minus AX, and for J is equals to I, A of J is just going to be 0, right? So we have created one 0. Okay. Conversely, conversely we can prove, that to make a 0 you always need to choose x is equals to some value of ai. Okay, if I choose some x, if I choose x not equals to any ai, okay, for all ai, for all I, x is not equals to ai. Okay, then what is going to happen? So like bi would be what? Ai minus x. So all the bi's, so bi is not equals to 0 for all I, right? So in that case, my mx is just going to be 0. Okay. So whatever x I am choosing, it has to be one of the AIs, right? Either A1, A2, or till AN. So whatever x I am choosing, it has to be this. And uh, since since n is less than or equals to 1000, we can brute force by doing what? Like we can brute force by choosing x is equals to a1 for once, then we'll choose x is equals to a2 and check for this x what is my mex for, and I'll check for this x what is my mex, and for x is equals to a3 I'll check what is my mex, okay, and so on. And like since there are n number of x's, we'll have to check the mex in order of n, right? uh, which would eventually lead to what? Which would eventually lead to our complexity of big of n square. Okay, so like it is a very I'm sorry. So it is a very common task to calculate the MEX of an array in n or n log n, or right, like n or n log n. It is a very common task. Right. So let's look into the implementation for once. So so this is what I have done. So yeah. So I have taken the input and then I have sorted the array, right? And then I am for every I am choosing AI, like I'm choosing x is equals to AI. Okay, so then I am getting the new array, which right. So my new array would be what? My new array would nothing be just AJ minus AI if I'm choosing the ith element, right? And in this transformed array bj, I have to calculate the mex. Okay, so this is one way of calculating the mx. So I have declared one variable starting with initializing it with 0, and if bj is equals to this value, then I am just incrementing this value. Okay, and whatever the value is in the end, it is going to be my final answer. So, but to apply this, your array B has to be sorted. Okay, array B has to be sorted in non-decreasing order. Okay, so that's why I've sorted my original array in the first. And when I'm doing this transformation, like when I'm just shifting with AI, it is going to remain as sorted. Okay, so then I can calculate my MEX but by writing just this 4 lines of code. Okay, and my answer is what? My answer is maximum of all this MEXs. Okay. So the overall complexity is just big of n square. Like I'm sorting before the n square step, so it is still big of n square, and the space complexity is just big of n. Okay, let's move on to the next question. So Bessie has an array of n integers, and Bessie performs m operations on the array. The ith operation sets some element of the array A. Like the ith operation basically involves adding some ci value to some element of the array A. Okay. And unfortunately, due to rising RAM cost, Basis computer has limited memory, and whenever any element of the array is greater than h, her computer crashes and every element in the array is reset to its original value. So what does it mean? So it means that if any AI becomes greater than h, then all the changes that you have done till now, okay, so that will get undo. Okay, so that is so those changes won't going to have any effect on the array that has happened till now. So after all the operations, I just have to output the array A. Okay. And what are my constraints? So like n and m both are 1e5. Okay. And h is 1e9. So what I can do? So I have been given an original array A, right? And I have some set of pairs. Okay. So what are those pairs? Those are pairs of idx, comma, some value c. So what does it denote? It denotes that like it denotes that on the ith operation I have to do what? I have to do a of idx plus is equals to c. Okay, so I'll have to add some value c to my uh, idx element. Okay, so and if some element and if a of idx becomes greater than h, Then make a is equals to a dash. What is a dash? A dash is the original array. A dash is the original array. Okay. So yeah. So let's say I have applied some number of like I have applied k number of operations, okay, or k number of changes. So if I have applied those first k changes, then after that my array A has been transformed to some array B, right? And after the kth step, some element has become greater than h. Okay. Then what is the easiest way to go back to my original array? Okay. So the easiest way to go back to my original array is just traverse through all the previous changes that has happened till now. Just traverse through those changes and do the reverse change. So what is the reverse change? So here I am doing a of idx plus is equals to c, right? So its reverse would be what? A of idx minus is equals to c, right? Minus is equals to c. So after the first k steps, if some element has become greater than h, then what I am going to do? I am going to just apply the reverse changes of the first k operations. Okay. What after this? So let's say after the k steps again, after some k1 number of steps, after some k1 number of changes, after some k1 number of changes, uh, again some element has become greater than h, then I am going to undo my operations for what? For the previous k dash operations only. I'm not going to do the reverse change for the whole of array, but only the previous k dash operations. Okay. So I have to maintain some kind of previous counter. So I'll have to maintain a counter or kind of a boundary. Okay. I'll have to maintain a counter for which indicates till where have I undo the changes, right? So if I have already undo my changes till let's say last, right? Then I only have to do the changes till last plus one, right? So if I have reached let's say kth change, then I just have to do till like this much change, okay, to get correct answer, okay. And you would notice that total number of changes is what? Total number of changes is equals to m, and total number of reverse changes is also equals to reverse reverse changes is also is equals to m, right? So since it is of the order of m, I can just simulate this reverse change, right? So like I don't have to think much. I just have to do the reverse changes for all the operations that I have to undo. Okay. So yeah. So let's look into the code for once. So here's the code. Uh, so I've taken the input and I see the variable last. Okay. So I'm maintaining this variable for what? So I'm maintaining this variable to keep track of till what index I have undo my changes. Okay. So I'm doing what? I am just doing I'm doing the change that has to be done. Okay. And if this element has become greater than h, then I am going to apply the reverse changes. Okay. So then how, so I am starting with the I am starting at index j is equals to last, right? And I am coming till this particular where I am standing. So till this particular operation, I'll come and then I am going to the reverse changes. So this is the reverse change. This is the correct change and this is the reverse change. Okay. And then I'm updating my last variable as I plus 1 and that's all. And then I'll just print my array. So, so the overall time complexity is big of n plus m and the space complexity is big of n plus m again, right? So let's move on to the next question. So there exists an infinitely long number line, and in that we have some robots, and there are some spikes. They all are located at some location, okay? And we are provided k instructions. So k instructions are provided to the robots, and with each instruction is either a move left by 1 unit or move right by 1 unit. Okay. So at each instruction, every robot will simultaneously move one unit to the left or 1 unit to the right. Okay. And for each I have to calculate what? For each I from 1 to k, I have to output how many robots are still alive after I number of instructions. Okay, and the constraints on n, m, and k are like nominal. Okay, 2e5, right? So, so we are given some infinitely long number line. Okay, like robots are there. Okay, so robots are there. Somewhere robots are there. Somewhere robots are there. And somewhere here some spikes are there. Okay, somewhere here spikes are there. Spikes are there. Spikes are there. Okay, like here is another spike, okay, and so on, right? So like at for k number of for k instructions, every robot will do what? Every robot will either shift by one, shift by one over here, right? Either plus one or minus one in their position, okay. And spikes are going to remain at their position, right? So spikes are going to remain at their positions, okay. And after every I number of instructions, I have to tell what? I have to tell that how many robots are still alive. So if any robot touches any spike, so let's say it touches this spike over here. So if it touches this spike over here, then this robot dies automatically. Okay. Yeah. So how can I do this? So first of all, you would notice that uh, like uh, let's focus on some particular robot. Let's say focus on this robot over here. Okay. So for this robot, only two things matters. What? Its leftmost spike and its rightmost spike. Okay. So if it has to, if it could die with this one, then it can obviously die with this spike only, right? So its leftmost and rightmost spike only matters, right? So since this is true, since this is true, for every robot, we can try to maintain some kind of data structure, which maintains for this robot what is its leftmost spikes distance with this element, and what is its rightmost spikes uh, distance with this robot over here. Okay, I should not say leftmost or rightmost. I should say like nearest left and nearest right. Okay, so yeah. So if I say So let's say for a particular robot, its left distance is some x and its right distance is some y, right? And after k number of steps, after let's say I number of steps, okay, so after I number of steps, I have moved, let's say p times right, and I have moved q times left, okay. Then what is my overall change with this? So my overall change is just going to be what? It is going to be p minus q times right, okay. It is going to be p minus q times right, right. And if this p minus q, if this p minus q is greater than or equals to y, then what does it mean? It means that I have moved right more times than I am allowed to. Okay. The, so that means that my robot will die if p minus q is greater than or equals to y, or if p minus q is less than or equals to x. Okay. Assuming that x over here is negative, right? So yeah, assuming that x over here is negative, so p minus q, if it is less than or equals to x, then again my robot dies. Okay, so my robot can die because of the either because of the left robot or because of the right robot, right? So what I can do is I can maintain in set I can maintain in set uh, for every element what is its x value and what is its y value, that is what is its like left robot's distance from this, like left spikes distance from this robot, and what is its right spikes distance from this particular robot. Okay, so I'll have to maintain two sets. Okay, and to specify like which value belongs to which particular robot, I'll have to like insert in pairs. Okay, so the second element has to be I denotes what? The index of this robot. Okay, similar over here, right? So what is going to happen? So I'll do something like this. Okay, so let's say my ith instruction comes and my position shifts by +1, or similarly for -1. So let's say it shifts by +1. So sum becomes what? Sum plus 1. Sum is what? Sum is just my overall change till now. Okay, so if it becomes plus 1, then what I'm going to do? I'm just going to do what? I'm going to check how many robots are there, whose right, which is y is less than or equals to sum. Okay, so how many such robots are there? So for all those robots, I will consider them as dead. Okay, and like if they are going to die, then I'll have to remove them from the set. Similarly, if sum is equals to sum minus 1, I'll do some similar thing. Okay, so let's look into the implementation for details. So yeah, so like A is just my vector which denotes the uh, robots. B is just my set which stores my spikes, right? So I'm storing this into a set because then I can just query which is my nearest left spike and which is my nearest right spike to some particular robot. I can do that in just what, like log of m. Okay, so and then I'm going to maintain this two sets left and right. Okay, and yeah, I'll explain what this L and R is. Okay, So for every robot, so its position is X. Okay. Then I am trying to find out what is its nearest right robot. Okay. So that is just my like the if you do upper bound, then you are going to find the position of the like nearest right spike. Okay. This y over here denotes what? This y over here denotes the distance. Okay. So the distance from this robot to its nearest right robot. So let's say if there is no robot in its right, so that distance is just going to be infinity. If it is there, if it is there, then that distance is just going to be my distance minus the robot's position. Okay, so position of the spike minus the position of the robot, and then I will insert y comma I. Right. Similarly, I am calculating the distance from the nearest left spike to this particular robot. Okay, so it is going to be this position of the spike minus the position of the robot. If there is no such robot in the left, then it is just what? It is just minus infinity. Okay, and then am I inserting in this? Okay, so this R and L uh, is not doing anything. It is just like I have just mapped them. So map them like what is the ith robots y distance. Okay, and what is the lth robots y distance. Okay, yeah. Okay, so yeah, why I have stored them? Because I have stored them because it they are going to be necessary while deleting something from left. Okay, like if I'm deleting in right, then to accordingly to delete in left as well, I'll need this value. Okay, here comes the character. So this character would denote what? It would denote if I am moving to the left or the right. So if I am moving to the left, my sum is decrementing. Otherwise, it is incrementing. Okay, and I have initialized my answer with what? I have initialized my answer with n. Like answer is initially and like all the robots are alive. So if while there exists an alive robot, okay, if some robot is still alive, then I am going to check what? I am going to just check that the smallest right distance is less than or equals to my sum. Okay, so if the smallest is right distance is while this is true, I am deleting this element. Like I am deleting this robot, and like accordingly, I am deleting the same robot from the left what like left like left shift. Okay, similarly I'm doing that for like if the largest left distance, so all the left distances are going to be negative, right? So if the largest left distance is greater than or equals to my sum, then I'm deleting this element from my left set, and accordingly I'm deleting it from my right set. Okay, and then after every instruction I'm just printing my answer. Okay, so that's that for this question. Let's discuss the time complexity. So the time complexity of this approach is just big O of I guess n plus m log n plus log m. Okay, so I haven't really like calculated in a like I haven't really calculated perfectly. It's just like the most like it is just an upper bound. Okay, so yeah, this is true. So and the space complexity is just big O of n plus m. Okay, so that's that. So yeah, let's move on to the next question. Let's read the question. So I'll explain the question for once. So there are some like 2 ki power n number of cows, okay, and they're playing some kind of game, okay, and like each cow initially is in one stack, okay, each cow is initially is in just one stack, and after every step, like after every second, something is happening, okay, and the value of a stack is just is XOR, like the XOR of the values in the stack, okay. So yeah, and after every step, uh, like something happens. So what happens? So every stack in an odd position is one third and so on. It starts a fight with the stack to the right. Okay, yeah, like the first fights with the second stack and the third fights with the fourth stack and so on. So the stack with the higher skill level will win the match. Otherwise, if there is a tie, then the leftmost stack wins the match. Okay, and the winning stack will jump on top of the losing stack and shift itself over such that no gaps left by the defeated stack. So this is basically means that the winning stack will position themselves on top of the losing stack. Okay, this is important because they have asked to calculate answer which relates to this. Okay, and yeah, like there are no gaps means they just basically shift each other's positions. Okay. So in order to make this more exciting, we have to answer Q queries. Okay, what is the query means? So the ith query means that we will set the skill level of some cow equals to Ci. So we will set the skill level of some cows, some ith cow equals to Ci. Okay, and then we want to find out this, like after all the matches, where would this cow stands in the stack? Okay, so the farmer John wants to know how many cows are above the cow that was given the portion. So whoever cow that was given the portion, that is whoever the jth cow whose starting value has been chosen was bi or set equals to ci. Okay. So for that cow, we have to tell how many cows are above this particular cow. Okay. Yeah. Yeah, and all the queries are independent. Okay, and n is equals to 118, and the sum of 2 ki power n is also doesn't exceed like 2 ki power 18. Okay, and queries are like 2e5. Okay, so how can I do this? How can we do this? We are given for n is equals like for big N is equals to 2 ki power n, we are given for every cow we are given its some initial value. Okay, yeah, so it is going to be a1, it is going to be a2, so on, and they are going to fight. Whoever has the higher value is going to win the match. Okay, so if a2 fights with a1, it is they are going to so A2 will win the match, and then what would happen? So A2 would be positioned above A1. Okay. Similarly, A3 might have been positioned above what? Above A4, and so on. And this goes on until we get some one final stack. Okay. One final stack whose length is what? Whose length is n. Okay. Capital N, which is 2 ki power n. Right. Right. So we are given some q queries, and for every query q we are given some index. So let's say this is the element. Okay, so this is the jth element which we care about, and we are setting its value equals to some x. Let's say we have set it as x, and then we simulate this game, and after simulating this game, whatever final stack that we get, we care about the position of x. So let's say the position of x is some y. Okay, then we care about how many cows are above this position, which is precisely what? Which is precisely capital N minus Y. Okay. We care about that only, right? So how can we do this? We have to do this for Q queries. Okay, so how can we do this? So you would notice that so if I try to simulate this game, so if I try to simulate this game, so after the first round, how many stacks would be there? So there would be total what? Like every two cows would have been merged. Okay, every two adjacent cows would have been merged. So there would be total what? 2 ki power 2n minus 1 stacks would be there. And after the second round, there would be 2 ki power n minus 2, right? So total there are order of n. Okay, so total there are just n rounds. So that basically means that so and n is what? N is less than or equals to 18, right? So there would be total just small n rounds. Okay. So this game won't last more than 18 rounds, right? So if I'm trying to simulate this game for a particular cow, okay, then how we are going to do that? So we are going to do in what way? So we are just going to do let's say my cow's index is I, okay. We will so for the first round we'll have to know that if this cow fights with I plus 1 or it fights with I minus 1, okay. And then according to the rules defined we will have to know two things. We'll have to know what. So if I wins or not, so if it wins then it's good. If it doesn't win, then some number of cows answer would increment by something, by some value. Okay. What is my answer? Answer is just my number of cows that are going to be above the cow which I care about. Okay. So if my cow loses, then my answer would increment by some value. Okay. Right. And to check which stack would win, to check that, we just need to know what? We just need to know uh, the XOR value, of the stack in which my current cow is, and the stack in which with which we are fighting. Okay, with which we are fighting, and yeah, that's that. And we just need to do this what? N times, which is 18. So Q into N is what? Q into N is acceptable. Our only bottleneck is to find these XOR values. Yeah, to find these XOR values. And we are going to we have to find the XOR values of some sub-arrays of some size. Okay. So of some sub-arrays of some size. So we can find the XOR values in just O of 1 if I have pre-calculated my XOR prefix. So if I have pre-calculated my XOR prefix, then just the XOR of so A of L XOR A of L plus 1 up until A of R is equals to what? Is equals to A of 1 XOR A of 2 up until A of R, right? And if you XOR it with what? A of 1 XOR up until A of L minus 1. These two are same thing, right? So if I have pre-calculated my XOR prefix array, then I can get the XOR values in just big O of 1. Okay. So let's look into the implementation to get a more clear idea. So as I said, I am pre-calculating my XOR prefixes. Okay. So I'm just pre-calculating my this XOR prefix vector. Okay. And for every query, like I'm getting the input. Okay. and then I'm trying to maintain some kind of range. Okay, so my current range is what? It is just my start. It just starts with what? Ith element and the ith element. Like it starts with ith element and it ends with the ith element. That is the cows. Okay. So the element by element I just mean the cows. Okay. What is my answer? So answer is the answer which is being defined in the question. Okay. And this current this current so this current variable over here denotes what? It just denotes what is my XOR value of this particular of the particular stack that my cow is in. Okay. And I am going to do this operation for what? I am going to do this operation for like I'm just simulating the game. Okay. So I'll be simulating the game. So the game will last for what? It will last for n rounds. So it is going to start with n rounds, and this lane over here just denotes the round. Okay. So first of all, I'm trying to find out what direction. Like, is it going to fight with the left stack or is it going to fight with the right stack? So this direction over here, so direction equals to 0 denotes that it is going to fight with the left direction. Okay. And this is the condition that I have put here, which checks if it is going to fight with the right direction. Okay, so what does this basically mean? So r plus 1 I have done. Why? Because like r I have taken as 0 based. Okay, so that's why I'm doing the plus 1 to make it 1 based. So if it is a perfect multiple of 2 की power round plus 1. Okay, so let's say I am in the first round. So in the first round, an odd element would fight with the uh, right element. Okay, so the cow who is at the odd indices will fight with its right neighbor. Okay, so what does it mean? It means that right. So we are checking with the 2 to power 1. So if it is so len plus 1 denotes the current round. Okay, so the parity with its current round. If it is equals to 0, then that means that we are going to fight with what? We are going to fight with my left neighbor. Otherwise, we are going to fight with my right neighbor. Okay. So this just denotes my direction. So so now I know the direction. So if the direction is 0, then what I am going to do? So then I am going to calculate the XOR value of my left stack. Then I'm just checking if that value is greater than or equals to the current value of my stack. If it is, then I am adding the whatever answer. Okay. So that answer is just like the size of the stack. Okay. Yeah. And then I'm doing what? Then I am just updating the XOR value of my current stack. Then I am updating my boundaries, and then I'm incrementing the round. Okay, similarly over here I am calculating the XOR value of my right neighbor, and then I am checking if y is greater than current. So you would notice that in the rules it was specified that if the XOR values are same, then the left stack wins. Okay, so if we are fighting with my right neighbor, then if the values are same, then by default we would win. Okay, so we are going to lose only when y is greater than r value. Okay, so if it is greater than r value, then only we are losing. So in that case only we are incrementing our answer, and then I'm updating the variables, and that's all. And then I'm just outputting my answer. Okay. So the overall complexity of this approach is the overall complexity of this approach is 2 की power n plus n into q. Okay, and the overall space complexity is 2 की power n. Yeah, that's that. So let's move on to the next question. We are given n arrays, okay, and the following things is being performed exactly once. Okay, so yeah. choose some array, okay, like a1, a2, like every element over here denotes a full-fledged array, okay. So we choose some array. Let's say I have chosen the ith array, and then I'm going to choose some element in this array. Okay, so let's say I have chosen the jth element. Then what I'm going to do is I'm going to choose some other array which is not equals to this ith array. Then I'm going to do what? I'm just going to so let's say I have suppose the kth array. Then I'll append this jth element of the ith array to the back of what? To the back of kth array. Okay, and then I'll remove the and then I'm going to remove the this particular aij from ai, and like I am just appending aij to ak, and I am removing it from ai. Okay, and the value of this operation is defined as the sum of each array's mex. Okay, so so after doing this operation, so whatever the sum of mex of sum of the mex I have got, that is just going to be my answer. Okay, and we have to do what? We have to evaluate the sum of the values of all possible distinct independent operations. Okay, and two operations are distinct if the ordered number of integers, that is I, j, k. So every distinct operation that I can do, I'll have to calculate the answer for that, and then I have to take a summation for all those things. Okay, and the size of like the total sum of the sizes of the arrays doesn't exceed what? It doesn't exceed 2 ki power 5. Right. So what can I do? Right. So some arrays are there. Okay. Some arrays are there. Some array are there. Okay. Some array are there. Right. So if I'm choosing this element from here and I'm deleting from that, and if I'm appending it to this element, so what does it do? Has this array's MEX been affected? No. Has this array's MEX has been affected? No, it hasn't, right? So if I am choosing ith array from from which I remove, and jth array to append the other n minus 2 arrays MEXs doesn't get affected, right? Doesn't get affected, right? Also also so if I am choosing let's say this is my array which I am choosing from which to remove. So if I have chosen this element, so let's say this value is some x. Okay, if I remove this value from x, obviously it may or may not change the mex of this particular array. Okay, but if I am going to insert it into some other array, so if I'm going to insert it into some other array b, some other like or rather a of k. Okay, if I'm going to insert it there, then how is it going to affect over here? So how is it going to this array over here? So initially my mex was something x, but after I have inserted this x, my mex would either be x or some y. But what is y? What is y? So y is what? So my claim is y is just my second mex. Okay. So what is second mex? So second mex is just the second Second smallest non-negative integer that doesn't appear in array. Okay. So my claim is if x is not equals to the mex of this jth array, then the mex of this jth array is just going to be my x. Otherwise, my mex of this jth array is going to be y. What is y? Y is just my second mex. Okay, and I have defined what second mex is, right? And as I said, all the n minus two other arrays, would still be unaffected. Okay, would still be unaffected, right? So, yeah, yeah, okay. So, uh, but still, like we can't really iterate over every j. What is j? J was the index of the array in which I'm inserting. Okay, so we can't really iterate over every j. Okay, so that would actually just going to lead to what? It is going to lead to the complexity of li into n. Okay, so that is unacceptable. We have to remove this n part, right? This is acceptable. Okay. One more thing. So one more thing. Inserting this would change my MEX only if the X I am inserting is exactly equals to the MEX of the second array. Okay, so if the second array has the MEX is equals to X, MEX gets changed to the second MEX. Otherwise, it stays the same. Okay, so what I can do is I can I can do something like So I can do something like for every element, like for every array, I'm going to traverse, and in every array, I'm going to traverse to some element. Okay, so I'm going to traverse over its element, and whatever this value is, let's say this value is x. Okay, then I'm going to check. Then I'm going to check. So like I can remove it from if I'm removing it, then I can insert it any of the n minus one arrays. Any of the n minus 1 arrays, right? So there are total n minus 1 possibilities. So among all these n minus 1 possibilities, I'll have to check for all the arrays whose MEX is exactly equals to x, I will so those for those I'll have to for those I'll have to add the answer of what? So I'll have to add the answer of uh, second MEX. Okay, second MEX, right? Otherwise, for all those, my answers would be just X. Okay, yeah, right? Yeah. Okay, so if I have so for every array I'm going to traverse and for in and each and in every array I'm going to traverse through every its element. So if I'm removing this element, then again I have n minus one possibilities, right? So for all these n minus one possibilities, So for all these n minus 1 possibilities, I will get some number of answers. Okay. So for n minus 1 times, so its MEX would so n minus 1 times I would get what? I would get MEX. Okay, right? So n minus 1 times I am going to not MEX but a different quantity. So n minus 1 times I am going to get what? Summation of MEX. Okay. Summation of MEX. Okay, summation of MEX for every j not equals to I. MEX of the ith array where j not equals to I. Okay, we'll come back to how the ith arrays MEX would get affected. Okay, so for every j not equals to I am going to take a sum of MEX of I, right? And this answer is like my base answer. Okay, and for some number of arrays, like I would have got some second MEX. Okay, and obviously second MEX is what? Second MEX is greater than or equals to my MEX. Okay, like it is always greater than MEX. Okay, so what I can do is I can store in some kind of data structure, let's say a map in which I'll just map to what? I'll just map to, so for every MEX, I'm just calculate the sum of this, the summation of what? Summation of SMX, like the second maximum and maximum. So second max and max. So the difference of the second max and max, the difference of that, I'm going to I'm going to add all those, and I'm going to just store that in some kind of map. So in map, this MEX would be mapped to this value. Okay, this value over here, right? So yeah, if it if it would be mapped like this, then what I can do is, so as I said, I'm going to traverse through every array, and any every array I'm going to traverse through every element. So let's say I am at this element X. Okay. So for this element X, again I have n minus one possibilities. So for all those n minus one possibilities, I'll have to add this answer over here. Okay. So n minus one into summation of MEX j, sorry, and where j is not equals to I. Okay, so this is like my base answer. This is like my base answer. Okay, so this would get added no matter what. What other thing it would get added is this extras. Okay, so this extras. Also, we can prove one more thing. Okay, so in this quantity, in this quantity, S MEX of I minus MEX of I, like like in this quantity is the difference of second maximum of ith array and the uh, MEX of the ith array. Is it included in this quantity? Like this array is the ith array. Okay, is it included? It is not included. Why? Because MEX of ith array can never be x. MEX of ith array cannot be equals to x. Okay, like if x appears in this array, then we can say for sure that MEX of the ith array is not equals to x. Okay, so that's why we can just directly add into it. Okay, so let's look into the implementation to get a more clear idea. Okay, one more thing. So I have taken into account how the other arrays MEXs would get affected. But what about my ith array? Okay, so its MEX would get affected in such a way that, let's say its original MEX was this MEX. Okay, so its original MEX was this MEX, and if X is less than MEX and frequency of X is equals to 1, then this X over here becomes my new MEX. So X is my new MEX. X is the new MEX. Okay, new MEX. Otherwise, otherwise MEX stays the same, right? Like you can prove this. Okay, you can prove this. So if the frequency of X is greater than 1, then removing X, like frequency is greater than 1, then removing X won't really make much of a difference. Okay, and if it is equals to 1, but if it is equals to 1, but let's say this is my MEX. Okay, so this is MEX, but it comes after like X is over here, so X is greater than MEX. Okay, so if it is like this, then again it is not going to affect my MEX, right? So if these two conditions are true, then my new MEX is X. Otherwise MEX remains the same. Okay. For the ith array from which I am removing the X. Okay. Let's look into the implementation for that. So I'm just taking the input. Okay. So this just calculates the list of vectors, and this pair over here stores my first, like the pair of first MEX and the second MEX. Okay. So again, I have taken the input, I have sorted my array so that I can calculate my MEX in order of just M, the size. Then I'm calculating my second MEX, and then am I storing them. Okay. This SFM variable just denotes my summation of the MEXs. Okay. So I have calculated my summation, and this extra is just a map. Okay. So extra of some MEX. So like I'm just calculating the difference between the second MEX and the first MEX. Okay, so whatever that difference is, I'm just going to like add it in some map, right? As I said in my solution, right? Then I'm calculating my answer. So as I said, I will traverse through every array, and then I'll traverse through every element in this particular array. Okay. So this is my CSFM is just my current sum of MEXs. Okay. So current sum of first MEXs. So it is equals to what? It is equals to sum of first MEXs minus the first MEX of this ith array. Okay. Right? M is just the size of the ith array. Okay. And this is like I have just used this frequency map. This is what? This is just my uh, like is mx is max is just the like mex of this first mex of this ith array. Okay, so how am I calculating the answer? As I said, like for all the n minus 1 possibilities, this is my base answer. Base answer is what? It is just the sum of all the MEXs, all the first MEXs except the ith array's first MEX. Okay. And then I am accounting for the extras. Okay, whatever extras that I have got. So extras of what? Extras whose MEXs is exactly equals to X. X is what? X is just my EIJ. Okay. And then I am just checking how the MEX of my ith array is going to affect after this. So if this condition is satisfied, then Aij is my new MEX. Otherwise, the original first MEX is my MEX. Okay. So that is how I'm um, accounting for the change in the MEX of the ith array. Okay. And then I'm just calculating my final answer. So that's that. So the overall complexity is so the overall complexity is like summation of li log li. Why? Because I am sorting the arrays where I am calculating the MEXs. Okay. You may or may you can remove this log factor as well if you want, but like this is well acceptable. Okay. Yeah. So that is just my overall complexity, and I guess I have used a map as well. So that would just be what? That would just be uh, n log n. Okay. So yeah, that's just my. But again, summation of log AI is always greater than n log n, so it won't really matter much. Or maybe it will. Okay, so like just and I'll just rewrite. So it is just summation of li log li, okay, plus n log n. and the space complexity is just summation of Li log A. Okay, so that's that. So yeah, that's that. I hope you like the discussion. So I hope you like the discussion. Yeah, so thanks.